Traveling from Earth to other worlds isn't like heading to a neighboring city. It's a massive adventure that hinges on three key things: the mind-blowing distances, the limited speeds we can actually hit, and the fuel we've got on hand. Because of this, spacecraft don't just blast off in a straight line. They follow curved trajectories to save energy. And the further the target is from the Sun, the longer and more complicated the journey gets. For example, the distance to the Moon seems relatively short, at around 384,000 kilometers. But the Apollo spacecraft took about 3 days to get there because it didn't just fly in a straight line, it orbited the Earth first and then shot off on a curved path. If it had headed straight there, it would have taken way less time, but that would have required a massive amount of extra fuel. Mars is our closest neighbor and it's got everyone's curiosity piqued, but the distance between it and Earth swings wildly between 55 million and 401 million kilometers depending on where they are in their orbits around the Sun. Even so, you can't just blast off whenever you feel like it. You have to wait for a launch window that opens up roughly every 26 months when the two planets are in the perfect alignment. These windows are a total game changer because they slash fuel consumption big time. Using the most fuel-efficient route, which is called the Hohmann transfer orbit, the trip to Mars takes about 260 days. But some of the speedier spacecraft, like the Mars Reconnaissance Orbiter, made it in just 228 days, while the European Mars Express mission clocked in at only 201 days. Basically, the faster you go, the shorter the trip, but that really jacks up the fuel costs. Then we move on to Jupiter, the giant of the solar system, where the distance from Earth shifts between 588 million and 968 million kilometers. Because of that, a trip there can take anywhere from 1 to 6 years depending on the spacecraft's speed and its path. NASA's Juno mission, for instance, launched in 2011 and didn't arrive until 2016. That's nearly 5 years, because it followed a curved trajectory to use Earth's gravity as a slingshot to pick up speed. And Saturn is way further out, with its distance from Earth swinging between 1.2 and 1.6 billion kilometers. The Cassini mission took nearly 7 years to get there, launching in 1997 and finally pulling up to Saturn in 2004. If we could actually travel at the speed of light, we'd cross that massive gap in about 80 minutes, but our fastest current spacecraft are topping out at only around 70,000 kilometers per hour. If we wanted to head to Uranus, which is about 2.6 billion kilometers away at its closest point, the absolute fastest path would take roughly 9 years. To this day, the only mission to ever visit Uranus was the Voyager 2 flyby in 1986, and that journey took 9.5 years after launching back in 1977. This just goes to show that planning these kinds of trips takes serious patience that spans decades. And then there's Neptune, the furthest planet in our solar system, sitting at a staggering distance of 4.3 billion kilometers. Voyager 2's epic trek from Earth to Neptune took about 12 years, finally arriving in 1989. If we wanted to send a brand new mission today using high-tech gear like ion propulsion, we might be able to cut that down to 8 or 9 years, but that is still a seriously long time to be waiting. That's just for the planets, but if we're talking about straight up leaving the solar system, we're moving into science fiction territory. The Voyager 1 spacecraft, which launched back in 1977, is the furthest human-made object from Earth, and it finally crossed the boundary of the solar system into interstellar space in 2012. That journey took a massive 35 years just to cover a distance of 121 astronomical units. And remember, 1 astronomical unit is the distance from the Earth to the Sun. If we wanted to reach the closest star to us besides the Sun, Proxima Centauri, which is sitting 4.24 light-years away, even our speediest spacecraft, like the Parker Solar Probe, which hits a crazy 700,000 kilometers per hour, would take about 6,500 years to get there. Because of that, there's zero serious plan to send humans to another star using the tech we have today. So what actually determines how long the trip takes? First off, fuel. A rocket carries a super limited supply, and honestly, most of it gets burned up just trying to blast off from Earth. After that, the spacecraft relies on that initial kick of momentum and then hitches a ride on the gravity of other planets. If we wanted to double the speed, we'd need like 4 times the fuel, which is just totally impractical. Second, orbital mechanics. Since planets are constantly on the move, you can't just aim a spacecraft at where the target is right now. You have to aim for where that target is going to be years later when the craft finally arrives. It's exactly like a perfectly timed lead pass in football. You throw the ball to an empty spot on the field where the player is going to meet it. That's exactly why launch windows are calculated with such crazy precision. Third, the perfect timing, or that travel window that happens when the planets line up in a way that lets us use the absolute minimum amount of energy. For example, the window to head to Mars only opens up every 26 months and stays open for just a few short weeks. As for Jupiter, that window pops up roughly every 13 months. If you miss that window, you're stuck waiting years and years for the next one to come around. So, the bottom line is that interplanetary travel isn't the straight shot we usually imagine. It's actually a total art form of maneuvering, waiting, and super precise calculations. Every time we push further from the sun, the distances just blow up and trips start taking years, or even entire decades. Even so, humanity is constantly leveling up propulsion tech, like ion drives and solar sails, hoping to seriously shrink those travel times in the future.